Hello class, this is section 1.8 on inequalities. So let's look at this first example. We need to solve and express the solution using integral notation. So let's add 4 to both sides. 3x is greater than 24, divide by 3. X is greater than 8. So that's the solving part. Now the graphing part becomes, so you just draw a number line. Zeros in the middle somewhere. 8 would be over here off to the right. Because of the inequality not having the line on the bottom, that means it's an open circle. So open circle at 8. And then this means that you want this to shade the x values that are greater than 8. Greater means to the right. So we would shade to the right, and that would do it. All right, and the inequality, interval notation, would be all the values from 8 to infinity, but not including 8. So open parentheses means you're excluding 8. If this were a closed circle, then this would have been a closed bracket. And infinities always end with parentheses. So that would be your final interval notation. Let's look at the next example. Similarly, we need to solve, but first we need to distribute that -1. So that's 24 minus 3x less than or equal to -1 minus 8x. Let's bring everything to the left side. So we will add 8x and add 1. So that would become 25 plus 5x less than or equal to 0. Subtract 25. Should have left the 1 over there, actually, but that's okay. 5x less than or equal to -25. Divide by 5. X is less than or equal to -5. Careful when you're dividing by a negative number not to forget to change the direction of the inequality. In this case, we're dividing by a positive, so we're not going to change the direction. All right, to graph, we draw our number line. 0 is in the middle. -5 is somewhere on the left. This time it's a closed circle because of the line underneath the inequality. So that would be a closed circle at -5. And we want all the values that are less than. So that would shade to the left. Less than shades left. And the inequality that corresponds to that would be everything from -infinity this time to -5, close bracket. So inclusive of -5 because of the closed circle, but parentheses are around the infinity. So that would be the final solution for that problem. The next problem, this is called a compound inequality because you have 2 inequalities in one. So you just want to isolate the x in the middle. We can do that by subtracting 6 to both of the sides. So we're going to have -16 less than -2x less than -9. Divide everything by -2. And we're left with +8 less than x. Oh, however, we are dividing by a negative number. So actually these inequalities are going to switch direction. 9 over 2 is 4.5. We can just call that 4.5. It's probably a little bit easier to look at this way. X is less than 8. Let's see here. This is going to be x is, less than 8 and greater than or equal to 4.5. So you can switch this so that if you just look at that part there, that reads as x is less than 8. So I'm just rewriting it, but on the other side. And then same thing, this reads x is greater than 4.5, so I rewrote it this way. It's just a little bit easier when the inequalities are both going in this direction. So the graph will look like this. 0 is somewhere there, 8 is somewhere over here, 4.5 is somewhere over here. And you would do closed circle for the 4.5, open circle for the 8. And this means that you want to shade all the values that are in between. So your graph would be shaded in between. The interval notation would be everything from 4.5, which you can also call 9 halves if you prefer, comma, 8. I'm going to actually leave it as a fraction, but you can keep it as a decimal. WebAssign will accept both versions, decimal or fraction. All right, let's go back to this. Let's go to the next problem now. All right, so for this one, we need to first factor this trinomial. So if you factor the trinomial, you should get x. 48 is 8 times 6, and you want a negative 8 because you need a negative 2. So the two solutions would be 8 and negative 6. If you're treating this as an equal sign for now, just to get the two solutions. And so once you get the two solutions, you're going to go ahead and graph that. Negative 0 is here, negative 6 is maybe over here, positive 8 is over here. And so now we need to test the intervals. We need to test everything that's, we need to test the number to the left of negative 6. We need to test the number that's between negative 6 and 8. And we need to test a value that's greater than 8. So there's three values that we need to test. Test x is, I'm going to choose negative 7 as the test point. I'm going to choose 0 as my test point because 0 is between negative 6 and 8. And finally, I'm going to test 9 because 9 is to the right of 8. All right, so you can test them here and here, or you can test them here, wherever you prefer. I'm going to test them here. So if I plug in negative 7, that's going to be negative 15. So that's basically a negative times, if I plug in negative 7 here, I get a negative 1. So that's a negative times a negative. Is that less than or equal to 0? No, because this is a positive is not less than or equal to 0. So that would be false. So I'm going to put an F to indicate that it's false. Let's do that to the next point. So if you plug in 0 for x, you're going to get a negative times a positive. And that is true because a negative times a positive is negative, and a negative is less than or equal to 0. So that would be true. So false, true. Let's see what happens at 9. So if you plug in 9 and 9, you're going to get positive 1 times 15. So positive times a positive. And that is false. So our solution set would be, because of the inequality, we know that they're both going to be closed circles at both solutions, and you only want to shade wherever it's true. So the true would fall right in between. All right. So our final solution, our interval solution, would look like this. It would be everything from negative 6 to positive 8, closed brackets on both sides. All right, let's move on to the next problem. This one's similar to that last one we did. The nice thing about this one is it's already factored for us, so we don't need to factor it because it's already factored. So we can go straight to the solutions. The solution to this first factor would be negative 7. Remember, we're treating this as an equal sign for now. And then just so that we can get the solutions. So we got the three solutions, one that corresponds for each factor. We graph those on the number line. Negative 7, positive 5, positive 7. And these are also going to be closed circles, all three. Closed, closed, closed. And now we need to test 1, 2, 3, 4 intervals this time. So we're going to test some intervals. For the first x, I'm going to choose negative 8. For the next one, I'm going to choose 0. I always like to choose 0 because 0 is an easy number to work with, and 0 is definitely between 5 and negative 7. I'm going to choose 6 because 6 is between 5 and 7. And the last one I'm going to choose is 8 because 8 is to the right of 7. So let's test these. If you plug in negative 8 here, you're going to get negative 8, so that's a negative. If you plug in negative 8 here, you're going to get another negative. And if you plug in negative 8 here, you're going to get another negative. We want to know if that is less than or equal to 0. question mark. 3 negatives is a negative, so a negative is less than 0, so that is true. All right, same thing. Plug in 0 this time. 0, 0, 0. That's going to be a positive times a negative times a negative. Positive times a negative times a negative is that will be a positive, which is false. It's not less than 0. All right, the next one is 6. So 6, 6, and 6, that would be positive, positive, negative. Positive times a positive times a negative. That is false again, because actually no, this is true. Because you're going to have a negative is less than or equal to 0 is true. And for the last one, 8, 8, 8, 8, you have a positive, 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 positives. 3 positive makes a positive, which is false for this one. So our solution set will only be the trues. So it'll be here and here. So for that, our interval is there's going to be 2 separate intervals that we're going to combine with the union symbol. So for this interval, that's going to be negative infinity to negative 7, close bracket, open bracket, or parentheses, union, close bracket, 5 to 7, close bracket. That will do it. All right, now we're going to deal with inequalities with rational expressions. These are a little bit harder. So first thing you want to do is make the right side equal to 0. And so we need to subtract 3 over. So 6x over 2x plus 7 minus 3 greater than 0. All right, now you need a common denominator because you need to combine these 2 terms into one term. So the LCD, or the common denominator, would be 2x plus 7, 2x plus 7. So now we have a common denominator. So, and then we would do 6x minus 3 times 2x plus 7. So after you distribute, you're going to get 6x minus 6x minus 21. So you're going to get this cancellation. You're going to get negative 21 over 2x plus 7 is greater than 0. So finally, now we can look at this problem and determine what are the values of x that would make this undefined. So you set the denominator equal to 0, and you solve, you should get negative 7 halves. So if x is equal to 7 halves, then this would become 0, which you cannot do in math. You cannot divide by 0. So this means that x cannot be that. So that's our first thing that we would do. X cannot equal this value, therefore it has to be open circle because that's not part of the solution set. If it were, you would get undefined. So therefore you have to make sure that you write an open circle there. All right, then normally you would set the numerator equal to 0, but in this case there's no variable, so you don't want to do that. You only want to set the numerator equal to 0 if there's a variable up there. But if there's not, then at this point you would just test these 2 intervals to see if it's true or false like we've been doing. So I'm going to test 2 points. 1 point would be to the left of this number. This is negative 3.5, so I'm going to test negative 4. And then to the right would be, that would be like any number you want. That's to the right of negative 7 halves, which I will choose 0, my favorite number to test. So if I plug negative 4 into here, that's going to be, let's see, you can have negative 21 divided by negative 4, 2 times negative 4 is negative 8. Negative 8 plus 7 is negative 1. Is that greater than 0? It is, because a negative divided by a negative is a positive, and therefore that is true. If you plug in 0 here, you're going to get negative 21 over 7. Is that greater than 0? No, that is less than 0, so that would be false. And so your solution set will only be the left side. Interval notation, that would look like negative infinity, comma, negative 7 over 2, parentheses on both sides. All right, there's one more problem. This one is very similar to the one that we just did. So we have to bring, whenever you have rational expressions involving an inequality involving rational expressions, you always have to make one side of the inequality equal to 0. So I'm going to bring this term over. So we have 1 plus 56 over x plus 1 minus 56 over x less than or equal to 0. Similarly, we need to combine these three terms into one, so we need an LCD. Right, so the LCD will be x times x plus 1. So if you turn this into a fraction, you're going to multiply this by x plus 1, top and bottom. This one, you're only going to multiply top and bottom by x, because that's the only thing that's missing. And over here, you're only going to multiply by x plus 1. And now you have a common denominator. So if you write this out, you're going to get x plus 1 plus 56x minus 56x plus 1 less than or equal to 0. And of course, we need to distribute and combine like terms. So we have x squared plus x plus 56x minus 56x minus 56 all over the LCD less than or equal to 0. These are going to cancel out. And so now we have x squared plus x minus 56 all over our LCD. This one, trinomial will factor, which is nice. So let's factor the trinomial. Should get x plus 8, x minus 7. So now we have the situation that we had previously. You set the denominator equal to 0 to figure out what values are excluded from the solution set. So if you do that, you're going to get x equals 0, x plus 1 equals 0, so x equals negative 1. So I set the denominator equal to 0 and I solved, and I got these two solutions. So that means that x cannot equal those values because otherwise you get undefined. So at this point, I would draw my number line. I got 0, I got negative 1, and I want open circles because x cannot equal those values. All right, so we took care of the denominator, check. Now we got to take care of the numerator. So you do the same thing. You set the numerator equal to 0. And you get two solutions as well. In this case, because there's an equal sign here, that means that these values are part of the solution set because it can equal 0. If it didn't have this little line on the bottom, you would do the same thing, cannot equals. But because of the line, that means it can equal. So for these two values, we want closed circles. So negative 7 would be over here somewhere. And then that's negative 8. And positive 7 would be over here somewhere. So for those, we do want those circles to be closed because they're in the numerator and it's got the equal sign on the bottom. All right, so same as before, you got to test this interval, this. So there's 1, 2, 3, 4, 5 intervals to check. So it is kind of a lot of work, but let's choose our values that we want to test. So I will test negative 9. I will test negative 2. I will test negative 1/2. Unfortunately, we have to go with the fraction because of this. And then we can choose 1, and finally 8. All right, so I'm going to kind of do this a little quickly. So if I plug in negative 9 here, this is going to be a negative. So we got negative divided by negative. So you got 1, 2, 3, 4 negatives, which makes a positive. Is that less than or equal to 0? False. All right, for the next one, negative 2, this would be positive. Negative 2, that would be negative. On the bottom, you would have a negative and another negative. So you have 3 negatives, which makes a negative. So overall, that would be a negative, which would make that true. All right, now let's go with negative 1/2. That would be positive. negative a half, that would be negative. And that would be a negative, and that would be a positive. So for negative a half, I'm getting 2 negatives and 2 positives, which is a positive, so this would be false. All right, for 1, if I plug in 1, 1, 1, 1, I'm going to have a positive. I'm going to have a negative. I'm going to have a positive and a positive. Whoops, positive, positive. So that's 1 negative, which makes it negative, so this would be true. Finally, plug in 8. That's going to be positive, 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 positive. 4 positives makes a positive, which this would be false. So our solution set would be true, true. All right, so that would be written as negative 8, close bracket, negative 1, parentheses, union, parentheses 0 to 7, close bracket there. That is our final solution. That concludes this